Alright, this is the video for the homework that I gave the day of the PSAT. It's 1.5 AP free response problems. These are pretty meaty problems, so I made a video as far as my solution guide went so that people who don't know how to do it would follow along, and the people who do know how to do it can skip through and see what I write for answers and stuff like that. Alright, so our question here, we have a skate ramp apparently. It's always increasing. If you've ever seen skate ramps, they look somewhat like this. So at x equals 0, the value of the function is 0, and the slope is 0. So it's some sort of parabolic thing. So the first thing we do in the problem is we go, hey, let's try a parabola. But we have this other condition. At x equals 4, so here-ish, we go up to 1 high. And the slope here is 1. So we have some special conditions here. We're going to test these with our quadratic and see if it works out. Now the problem tells us it's not possible, but we have to show why. So first things first, I'm going to take my equation, ax squared, which is f of x, and I'm going to take the derivative of it, because I know I have to use slope somewhere in this problem. So f prime of x is equal to 2ax. Now I'm going to take the given information that was in bullet point number 2, which is that x equals 4, f of 4 is 1, and the derivative at 4 is 1. So I'm going to plug this information now into these equations. This means x equals 4 when f of x equals 1. So 1 equals a times 4 squared. And same thing here. 1 is equal to 2a4. And now if I solve these two equations, pretty easy stuff. I divide by 16 on both sides. I get 1/16 equals a. Here I divide by 8 on both sides. I get 1/8 equals a. And that's no good. That's it for that. All right, that was A. On to B. B, now we're trying a cubic function. The cubic function they give us is that g of x is equal to cx cubed minus x squared over 16. Same idea. I'm going to find the derivative of this thing because I'm going to have to use that to make sure the derivative is equal to 1, 2. And I get 3cx squared minus 2x over 16. Now the same kind of idea applies here. G of 4 is going to be equal to 1, and g prime of 4 is going to be equal to 1. So now I'm going to plug the stuff in, and I get 1 is equal to c times 64. That's what 4 cubed is. Minus 16 over 16. And if I plug in the stuff here, I get 1 is equal to 3 times c times 16 minus 8 over 16. All right, I'm just going to solve both of these. This is 1, so I'm going to add 1 to both sides. 2 equals 64c. And then I'm going to divide by 64 and get 1/32 equals c. On the other side, I'm going to add a half to both sides. And I'm going to get 1.5 equals 48c. And I divide by 48, and miraculously I get 1 over 32 again, or 1.5 over 48, which is 1 over 32. Yeah, so these match. So we can prove that this does indeed work. We can get that condition with a cubic function like this. However, in C, they tell us that it doesn't work. It doesn't meet requirement 3. And then what they say, what requirement 3 says is that the function is increasing, which means that we need to find where the thing is decreasing. Now, decreasing means going down, which is negative slope or negative derivative. So I just need to see if the derivative can ever be negative. Thankfully, already have the derivative. It's up here. Yoink. So I need to see if this thing can ever be negative. Now I know c is 1/32, so I should just plug that in right now. And I get g prime of x is equal to 3/32 x squared minus 2/16x. And what I did here was I factored out 1/32 and an x. So I got 1/32 x times, and all that's left here is 3x, and all that's left here is 4. So now I know where the zeros of this thing are. They're at 4/3 and 0. But I can also see that this thing's going to be negative all the way from 0 to where this thing flips to being positive, which is where we plug in a number big enough in x that this thing will be positive, which is till 4/3. So all the way between 0 and 4/3, this thing is negative. So this is proof of why this thing doesn't work. So now on to the last part, D here, which is that we're going to use a new model that hopefully does everything we want it to. So we're going to use x to the n over k, which we are calling h of x. Now, I'm going to rewrite this real quick. A lot of people get kind of foiled by the k thing. They tell us k is a constant in the problem that we're going to find the value of. So I'm going to write this as 1 over k times x to the n to show that x is the only thing I'm taking the derivative of. Now we have the same conditions. We have that h of 4 equals 1. And we're going to take the derivative of this thing, which is just n times x to the n minus 1 over k because of this k. So the n is because I pulled down the power. They said n was a constant in the problem, so it's like x to the third. Our derivative would be 3 times x to the 3 minus 1. It's that kind of idea. So this is our derivative here, our h prime of x. So I'm going to set these two things equal to 1. So h prime of 4 equals 1 and h of 4 equals 1. I'm going to set this one, or do this one first. So in this one, I get 4 to the n power over k equals 1. And in this one, I get 1 equals n times 4 to the n minus 1 over k. These look pretty similar. This one's going to be a lot easier to solve for one of the variables because I just multiply by k. So I'm going to do that. K equals 4 to the n. Now I'm going to plug it in for k over here. And I get 1 is equal to n times 4 to the n minus 1 over 4 to the n. And now you might remember that I made you do all those exponential notation things because this is really a relevant example of where we'd use that. I can simplify this by just subtracting n from this exponent. When I divide, I can subtract in the exponent. So I get 1 is equal to n times 4 to the n minus 1 minus n, so just 4 to the minus 1. And that's like way simpler. All right, so this means a fourth. I can multiply both sides by 4 and get 4 equals n. Huzzah. Now I can find k. K is 4 to the fourth because n is 4. And so k is 256. And I've done it. Now I need to show that this meets requirements 1 and 3. First of all, this is an exponential function, so it's always increasing. So for requirement 1, I just say the thing is exponential. It's always going up. For number 3, it says, oh, did I swap those? Whoops, that was number 3. For number 1, so 3 is the one where it says it always needs to increase. So 1 says when it's 0, when x equals 0, the value of the function is 0. So let's test if that's true. So if I plug in 0 for n, I get, okay, so k is 256. So h of 0 is equal to 256 on the bottom And on the top, our x is 0 to the 4th. Well, it turns out 0 to the 4th is 0 divided by 256. We're good to go. Now the slope needs to also be 0, so I plug stuff into that. I'm going to do it over here. So my slope, my h prime of 0, that's going to be n is 4 times x to the 3rd power over 256. Love announcements. Alright, so if I plug in 0 here, I also get 0. And so this thing I have now verified. It works for condition 1, which is that the slope is 0, and the function is 0 when x is 0, and condition 3, which says it always goes up.